Hello guys. Okay, so today I'm going to continue from where I stopped the last time. So the last time we learned about, I said we are entering our what's it called, a subtopic called negative angles. And values. Under this we treated negative angles. And these were the three identities, the three trigonometric identities, the three axioms that we learned from negative angles. We said that if we have sine for any negative angle, it's going to be equal to negative sine of the angle. So this is just to brush up on what I did last time. Secondly, we talked about if we have cosine of a negative angle is equal to cosine of the angle. If we have tangent of any angle, any negative angle, or we have tangent of any negative angle is equal to negative tan of the angle. Negative angle means if you have, say, sine of minus 210 or tan of minus 210, you can convert it to some number. Okay, so like in order to show you how I'm just going to show you, I'm not just going to show how I came to this conclusion. So I said all angles are measured from the positive x-axis and clockwise. So we measure from 0 to 45 to 90 going this way. So that's anti-clockwise. If we measure an angle negatively, say the angle is here, and we say this angle is phi, we can write it in two ways. This angle can be written in its positive form and its negative form. Because you're measuring from here, any angle, let's say you measured 45 degrees here, right? What your answer will actually be is negative 45, because you're measuring yes from the x-axis, but clockwise. So it's going to be negative. So it's going to be negative here. So we call this remaining angle alpha. But then we know something. We said, or not I said, it's something we know. We said angle at a reflex point is on the plane geometry and circle geometry. Reflex angles, or angle at a reflex point, something like that, is equal to 360 degrees. So this whole thing makes up the reflex angle. So phi plus alpha equal to 360 degrees. So we know this is a negative number, right? But what we're doing is we're taking the absolute value. We're taking the absolute value of the angle, the negative angle, so it becomes positive. So we say this is equal to 360 degrees. Therefore, alpha is equal to 360 minus the absolute value of phi. So we say the negative angle can be written in terms of alpha or phi. So yeah, that's that for that. And then we did some examples for you to determine all these things. So let's say we had, I'm just going to do like a random example. Let's use 45. Let's use 45. Let's say we had sine of negative 45. The two ways we can do it. We can do it normally by just saying, using this identity. Yeah. Sine of negative of an angle is equal to negative sine of 45, right? And so that's equal to negative root 2 divided by 2, right? But then we can also go further and say sine of negative 45 is equal to sine of 360 minus 45. So that's going to be 15. And we know this is in the fourth quadrant. Sine is negative in the fourth quadrant. So sine (360) minus 315, that's equal to negative sine 45, which is equal to negative root 2 divided by 2. So that you can actually do that for cosine. And the reason why cosine comes out negative is because you're doing 360 minus the angle, and that's only true, and that's only positive for cosine. So that's about that. So this is just like a briefing of the last what's it called? The last video. After this video, after this section, because this is going to be section 2, after this section, my section 3, or I don't know if it's going to be a section, because I want all sections to just be purely about just like, concepts and ideas and, proofs and so on and so forth. Then maybe after section 2, I'll do a video to break down everything I did in section 1 and section 2, and then we can run through some examples, because I really hate doing examples, legit. So okay, now today we'll be entering negative values. If we say, should I do? Okay, this is a summary of what we're going to be doing today. We're going to, if time permits me, because most of what I'll be doing today is just deriving and proving. So I'm going to go to negative angles real fast. I'm going to go to trigonometric identities. This is how we call it in trigonometry. So we call these axioms, we call these axioms. I'll show you the 3 trigonometric identities we have. We derive that from right angle triangles. So we call these axioms statements that are true. So I'll talk about trigonometric identities, negative angles, and then negative values, and then I'm going to derive the addition formula. That's going to be the biggest. That's going to take most of the time. So let me just dive in straight without talking too much. So we know these are true. So negative angles. Let's go to negative values. Okay, this is how we're going to start. We're going to use the same triangle to explain everything. Okay. Hypotenuse. This is really bad. So hypotenuse opposite adjacent. Yeah, this is beautiful actually. C A B. Let's call this X. if we said what is sine x, we know what sine x is. Sine x is b divided by c, right? What is the value here, and what is the value, and what's the angle? You can never have sine of a number, because this is a function that gives you a number, right? So this is the number, and this is the value, and this is the angle. So sine of an angle, it's a function. It gives you, it's an input that gives you an output. So this is the input. Sine, we're using the function to get an input. This special function sine to get an input, which is based on the opposite of the triangle divided by the quotient of the opposite of the right angle triangle and the hypotenuse of the triangle. So it's a quotient. I mean, all quotients are inherently products, because you can say it's the product between the opposite and the inverse or the reciprocal of the hypotenuse. So this is the value and this is the angle. So we've already done negative angles, so we're going into negative values now. So let's say let's say this triangle, I don't know if you get, let's say this triangle doesn't follow real number system, that it has like complex, that would be too ambiguous to even define. Let's say, okay, for the sake of analysis, let's say we're trying to define sine function from 0 to 360 degrees from, so this is 0, this is 270, this is 270, this is 180, this is 0, this is 2, yeah, because sine maxes out at 90 degrees, so it's going to have its maximum value here and its minimum value here. So because there is no scalar factor for sine, we're not using any scalar factor to define it, so we can put 1 and -1. It doesn't pass 1 and -1 normally. So let's say we want to define, before I make that statement, I want you to understand something about algebra. So if we have any xy plane, normally what we do is the independent variable is going to be the x-axis, and the dependent variable is going to be the y-axis. So we just vary x to get an output. So in other words, the input in any xy plane, in any in two-dimensional function like y equals x squared, y equals let's say x cubed, or any quadratic equation, the input is the x value. You input anything for x and get your y, so y is the final output. So you're trying to get output by mapping out coordinates from x. If you say, let's say x equals 1, x equals a half, y, let's say x equals negative any number, so you use that to get your y. So that's the basic. So this is what we're trying to do. We're trying to explain this graph, the second portion of this graph. We're trying to define it from this point, 180 degrees to 360 degrees. That's why we called it negative values. Because all sine functions, all the inputs in this graph will always give you a negative number. I don't know if you understand that. So all the inputs in this section of the graph from 180 excluded, from 180 to, I don't like writing degrees actually. It's weird. From pi to 2 pi. Excluded, okay? If I had written like this, from pi to 2 pi, that simply means that 180 and 360 are included, but that's not the case, because 180 and 360 sine of those angles will give you 0. Oh, is it? Yeah. Is it? Yeah, sine of those angles will give you 0. So sine of this, so it's not included. So anything from pi to 2 pi excluded from this boundary. So this is the boundary condition. So we're trying to define this contained function where every input in that function from pi to 2 pi gives us negative values. So as I said before, there's no scalar factor to stretch the graph or compress the graph or something. So let's say we have sine of x equal to b divided by c. If you wanted to solve, sorry, if you if you wanted to solve for b, for this quotient, I said serve. If you wanted to solve for this quotient, we have b divided by c equals to sine x, right? Not so. Jesus, Oscar. B divided by c is equal to sine inverse. So this is the inverse function actually. Just like when you have, let's say, y equal x squared. If you solve for x, you have x equal to the square root of y. Okay, plus or minus the square root of y. Right? Normally we can say f of x equal to x squared. If we solve for the independent variable, we write it as this: f inverse f prime. Why am I making mistakes? F inverse of x equal to the square root of y plus or minus. So the f inverse of x is simply f of y. It's a function of y. Okay, so that's that for that. So this is what we're trying to do. What we're trying to do is this is only true for, let's say, for negative values actually. Yeah, for negative values. For any value, what's happening to me today? For any value, so b divided by c equals sine inverse of, jeez, I don't know what's happening to me. Okay, to be honest, I have been working the whole day, like, this. X equal to sine inverse, because I was like, this only works for, like, what did I write? B divided by c. I'm really sorry, guys. I don't know what's happening to me. What kind of mistake is this? B divided by c equal to sine inverse of x. That's stupid actually, because therefore I'm saying b divided by c. I'm simply saying that sine x is equal to sine inverse of x. This is not true. Okay? It's not true. It only happens for very small values of x. So this is what I was looking for. I don't know what happened to me. So ignoring the triangle for a while. So b divided by c, it's clearly a positive number. But let's say ignore the triangle, because the length of a triangle can't be negative, because I'm trying to explain negative values in it. So the length of a triangle can't be negative. So ignoring the triangle, let's just put a random number a. This is just used for analysis. So I said sine x equal to sine inverse of a number, of a negative number a. Okay, this is what I've written here, right? This is the note. Okay, so x equal to sine inverse. This is what we're doing the analysis. I'm writing it out here. Negative a. Therefore, if we solve for negative a, that should be equal to sine x. Right? That makes x equal to sine inverse of negative a. And this is what I'm saying. This is a negative value, right? Look at the beauty. We are trying to explain this function from 180 to 2 pi within that constraint, but doesn't include it. So from 180 to from pi, I don't like using degrees. From pi to 2 pi, excluding those boundaries. The only way sine of an angle can be negative is if you define it with this boundary conditions. So, in order for this to be true, our angles have to range from our angles have to range from theta should be less than 270 than 360 and greater than makes it less than 180. In order for you to have a negative number, let's look at something. When I was doing my first section video, I said sine is positive in the third and in the fourth quadrant. That happens to be where this whole periodic function is defined to be negative from the third to the fourth quadrant. Beauty. So that's how we actually say this. So in order to just solve the whole thing, we know that we reduce angle. So it's negative in the third and fourth quadrant. So in the third quadrant, we reduce angle by saying that angle, this angle, let's use this into theta. That angle minus 270 equal to something. Equal to, because this is an angle, right? So it's in the, so for sine it's going to be theta minus 270 because it's negative in the third quadrant, minus 180. Making mistakes. Is equal to sine inverse of a, the positive, take the absolute value and get the positive, or because it's negative also in the fourth quadrant, so it's 360 minus, okay, wait, I made a mistake. Let's call this x, because there are two things here, two angles actually. 360 minus, this is going to be the variable, okay? This is going to be the variable of what you're solving for. So 360 minus the variable is equal to x actually, and x, well, absolute value of x, because sine of negative a, what am I writing? So let's get an inverse here. So inverse. Really sorry about my, I don't know what's happening to this thing. So 360 minus this is the absolute value, is sine inverse of the absolute value of the argument. So it's going to be sine inverse of a. So let's say, let me just clear this in your mind. Let's say we had find the possible values for sine, the possible angles, sorry, for sine inverse of negative root 2 divided by 2. Oh no, sorry, mistake. Yeah, let's use that. So what we do is, we say, since this is negative, we say, this is the variable we're looking for, minus 180 is equal to sine inverse of the absolute value of this root 2 divided by 2. This makes it more difficult, because let's use a different number. Christ. Give me a different number. I know what I'm saying. It's minus 180 is equal to, it's meant to be inverse, not sine of root 2 divided by 2. Is equal to sine of root 2 divided by 2. That's 45 degrees. So if you solve for theta here, that's going to be 135. 130. What? No. Sorry. It's going to be 180 plus 145. That should be around 225 degrees. 225 degrees. Just to clear that up. And then this is the first value of the angle you can get. So when it's solve for the possible values of sine inverse of root 2 divided by 2, theta equal to 225, or it could be 360 minus the variable equal to sine, that's 45. It's a negative, that is equal to negative 315, and theta is equal to 315. Really sorry for my clumsiness today. But this is the fact I'm trying to get to you. I am so tired. I have been walking and working all day. I want this to be my work, actually, teaching. Just so you know. So that's the fact. So that's for sine. You can use this idea to derive for tan and cosine. I don't want to clean this triangle, but it's beautiful. That's the straightest line I've ever drawn in my life. Okay, x equal to sine inverse of a. Oh, my sine inverse of a. Okay, so I know something. I know that cosine is negative in the second quadrant, so it's going to be 180 minus the variable I'm going to be looking for is equal to cosine inverse of the absolute value of the value. Yes, of the value. Or I could say it's also negative in the third quadrant, so it's going to be the variable I'm looking for minus 180 is equal to cosine inverse of a. If I said x equal to, I'm really sorry if all these just feel ambiguous in your head. I promise in my next video I'm going to do some examples or something like that, because I really, when I'm studying something, I do like the examples later on when I've studied it for like a long time. Anyway, let's just keep going. So you say x equal to tan inverse of negative a. Okay. I guess all these two just come off bleeding, like they just come, it's obvious when you understand this, because our, yeah, it's pretty much obvious actually. So yeah, that's that for that. So now we've learned 6 things. We've learned these 3. Oh, you've also learned these 3. These are all true axioms. Oh my words. They're all true axioms in trigonometry. When this is actually very, 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 very useful. I'm telling you, most of the things you do in math are not even helpful in math. They are more helpful in when you're doing something in physics. Once, I think, yes, I think I'll do projectile motion with trigonometry because it's actually, if you understand trigonometry, then you can understand projectile motion, because, well, projectile motion has a little bit of algebra, calculus, mostly trigonometry. So yeah, most of all these things are actually very useful in physics. Once when you're talking about trajectory, projectile motion, I don't know. There are lots of things that you use all of these things. And okay, so that's that for that. So let's get into the main thing that everyone likes in trigonometry. Trigonometry. Okay. Not too bad. Same old, same old. X, C, A, E. Okay. This is the triangle I'll be using the whole day, or the whole video. Now, there are 3 things we can, there are 3 functions we can derive from this right angle triangle, yes? Those are, we can derive the sine function, and tangent function. We can also derive one more thing that everyone knows. It's a right angle triangle. What do you know about every right angle triangle? What we know about every right angle triangle is the square of the 2 sides gives you the square. If you add the square of the 2 sides, it gives you the square of the hypotenuse, right? So c squared. Okay, let me start by saying sine x. My writing is small. Start by saying sine x is equal to b divided by c, cosine x is equal to a divided by c tan x is equal to b divided by a. So we know these, eh? You also know there are derived functions. Cosec of x is equal to c, it's the inverse, c divided by b. Sec x is equal to c divided by, c divided by a. Yeah. And cut x is equal to a divided by b. Okay, so we know this, eh? We also know that from Pythagoras identity that c squared is equal to a squared plus b squared. Okay, let's divide all through by c squared. If you divide this by c squared, that will give you 1 is equal to a squared divided by b squared plus b squared divided by c squared, sorry, plus b squared divided by c squared. Okay, let me just write this part forward. 1 or a squared right. This is equal to right. But look at something. This is a divided by c. This is b divided by c. And they are squared. Can you see it? What's a divided by c? What's b divided by c? In my head, you're answering the questions. So, because I don't like writing cos x all squared, I like writing like normally. Cos squared x, that's the way it's written. Cos squared x plus sine squared x is equal to 1. Beautiful trigonometric identity, isn't it? That's the first equation. First identity. Second identity is, if you divide all through by a squared, that's c, let's start from a squared divided by a squared, that's 1, plus b squared divided by a squared, that's why that's b divided by a all squared is equal to c divided by a all squared. So what's b divided by a? B divided by a is tan. So 1 plus, that's tan x, tan squared x is equal to what's c divided by a? That's sec squared x. Beautiful, isn't it? So that's the second identity or second equation. Let's divide all through. Divide all through by. So I'll divide it by c, I'll divide it by a by b squared. So we have a divided by b all squared plus b divided by b, which is 1, is equal to c divided by b all squared. What's a divided by b? That's cot squared x plus 1 equal to what's c divided by b, cos squared x.